we'll be doing sequencers versus series. So, let's find the difference between the two. Sequence versus series. Okay, basically, what is a sequence? Well, a sequence is just a list of numbers. So 1, 2, 3, all the way to say infinity. That's a sequence. And now, what's a series? Well, a series is the addition of numbers. So let's just say these same numbers: 1 plus 2 plus 3 plus.
Look at you. What was it?
Oh yeah, and we're back. So yeah, as I was saying, sequence versus series. Sequence is a list of numbers. Series is the sum of those numbers. A series can be written in sigma notation. So, for example, it could be written as n equals, say, 1, and then, or just, infinity n equals 0. That's some examples of sigma notation. Okay, so what next? And it's okay. I'll go verbal for now, because we experienced some technical difficulties. So, how do you write summations? Well, for example, we have this 1 plus 2 plus 1 plus 2 plus 3 going on here. So you write as sigma n equals 1, since it starts at 1, and then infinity, because it goes on and on. And then what you would do is you would probably write n over here. And then, yeah. So 1, 2, 3, 4, and it would just keep on adding. Okay. Let me bust out better markers. Shout out to Orman. He suggested that I make videos, so props to you. Okay, so what can we say next? Well, an easy example of series I would think is factorials. Well, it's not so easy. Okay, so what we have here? We have summation n equals 1, infinity, and then 3 over n factorial. Okay, let me just explain what the factorial even means. So a factorial, basically, say you have 0 factorial or 1 factorial. These both are equal to each other because they're both equal to 1. I won't get too deep into it, but yeah, 0 factorial and 1 factorial. My bad, guys, for the technical difficulties. How about this? This time, I'll make the episode into not alive. I'll keep the live as is, but I'll make it not alive. And then for the next time around, I'll do it live, mic'd up and everything, fully professional, top, and we'll get cracking. Yeah, that's the plan. So, how about this? Since I froze, I guess. Let's see if I'm still frozen. No, we're good. Okay. Okay, so I'll just continue for now. So number 8. So for number 8, where is this? Alright. Alright. So for number 8, let's write it down. We have -1 plus 1 plus 3 plus 5. Okay. So since we have, what do we notice? This is increasing by 2 every time. So this is actually pretty simple and straightforward. What would you guys think? And it's important to notice that look, -1, 1, 3, and 5, they're all odd. So, okay, we have to use sigma notation for this. And what we would do basically is we would go sigma n equals 1. Up top we have infinity. And then, okay, so we notice it growing by 2, but we have odd numbers. And I guess we could say n equals 0. Okay, let's do n equals 0. So then, let's write 2n minus 1. I'll explain really quickly why. So we write 2n minus 1 because if you can see, this is all odd numbers. So this ensures that it's odd. Because if you multiply anything by 2, it's even. And if you subtract or add 1 to it, it becomes odd. So, and why do we do 0? Well, great question. Let's start mapping it up. So n equals 0. So that's the first term. So if you put 0 in place of n, you get -1. And then if you put 1 in place of n, you get 2. You get 2 times 1. It's 2. 2 minus 1 is 1. And then if you put 1, no, if you put 2, you get 2 times 2 is 4. 4 minus 1 is 3. And as you can see, yep, we got the pattern right. Okay, that was number 8. Alright, I'll do probably 3 from sections 10 to 29, and like to spice things up, I won't do them in order. So, which ones shall we do? Okay, why not let's do 10 and 12, and then we'll also do 21 and 22. Yeah, we'll do 4, and then I'll end the stream. Let me check footage. We're still golden. Okay, nice. We're rolling. Alright, so let's go with 10 first. So in 10, let's read the instructions for this section. Determine whether each of the following infinite series converges or diverges. Show this justification and name the test being used. In addition, find the sum of the series if possible. Okay, well, so what do we have for 10? Okay, I'll let you see. We have summation n equals 0, 5 times 2 over 3 n. Okay, off the bat, what is this? This is called a geometric series. Why is that? Well, this is in the form summation a r to the n or n minus 1. So, yeah. What is our r? Our r is 2 over 3. So, r equals 2 over 3. Okay, why is that important to us? Well, what do we want to do? We want to prove convergence or divergence. So, with convergence or divergence, first we got to take the absolute value of r. Well, we already know that 2 over 3 is positive, so even if we take the absolute value, it's going to stay positive. So absolute value of our r, 2 over 3, is going to be 2 over 3. And 2 over 3, is it bigger or less than 1? Well, it's less than 1. That would be said that. So if it's less than 1, we know it's converging. So the convergence is proven by GST. Okay, well, what does it say next in the instruction? In addition, find the sum of the series if possible. Well, how do we find the sum of this series? Interesting question. Well, there's a little known formula. Basically, you have to do, I'm writing the formula. Sum equals A1 over 1 minus R. Well, that one subscript is basically saying the very first number in this series. So we see n equals 0 there. That's the starting point. So 0. If we plug in 0 here, 0, 2 over 3 to 0 is obviously 1, and 1 times 5 is 5. So we do 5 over 1 minus r. Well, what is our r? Our r is 2 over 3. Okay, so you can see our r is 2 over 3, and now what? Well, 5 over 1, 2 over 3. Now we just gotta do simple math. 5 times 3 over 1. And we have 15. Is that right? And it is. Okay, nice. So our sum is 15 for 10, and we know that convergence is proven by GST since absolute value of r is less than 1. What would happen if it was greater than 1? Well, we'll see in the next problem. Let's check footage really quick. Okay, we're golden. So, what did I say? I remember saying I would do 12. So, let's do it. Well, 12 is really similar to this. So, I won't erase everything. 12 says same thing, but 3 over 2 instead of 2 over 2. Okay, and you'd be like, that's nothing, right? Well, it's something major. So, remember, still geometric series, right? We have a, r to the n, so geometric. And then we know this is our r equals 3 over 2. Okay, so to prove convergence or divergence, we gotta use the geometric series test. And geometric series test says, get your r, put it into absolute value, and compare it to 1. So 3 over 2 inside absolute value is still 3 over 2. It's positive, remains positive. So 3 over 2 is greater than 1. Well, what does that mean? Since it's greater than 1. Alright, we're back. So I wrote the next one down. Sorry if it cut off. This one's number 17. So 1 plus 0.2 plus 0.04 plus 0.08. Okay. Well, what pattern can we see here? This is number 17. Okay. Well, this might be geometric series. Okay, how would you check? Well, you have to find r. Well, we're not really given this in the notation that we're used to. So what we have to do is find r by dividing the second by the first, and also do the same for the third, but by the second term in this series. Okay, so what I mean by that is 0.2 divided by 1, and then we also do the same comparison for 0.04 and divided by 0.2. Okay. Well, this is going to be 0.2, and if you get your calculator out, this is also going to be 0.2. And since they match, we can conclude that this is indeed a geometric series. The ratios are matching. That's why we can conclude this. Okay. So now, we have a geometric series. Great. What do? We get the absolute value of r. What is our r? Our r is 0.2. We get the absolute value of 0.2 and we compare it to 1. Okay? So is 0.2 bigger or less than 1? 0.2 is obviously less than 1. Thus, we have convergence by GST. And again, that's the geometric series test. Check for footage. Okay, we're still rolling. Alright, this is number 17. If you want, I could do 18 and pop other questions in the chat, but yeah. Okay, so this is number 17. So we haven't finished this yet. We found that we have convergence by GST, geometric series test. What next? Well, next we have to find the sum if possible. And how do we do that? Well, remember, it was A1 over 1 minus R. Okay, A1, that's 1. Nice. 1 minus, what's R? 0.2. Okay. Well, what's 1 over 0.8? 1 over 0.8 is the same thing as 1 over 8 over 10, right? Yeah. And then afterwards, you flip that, you get 10 over 8. And if you end up dividing it out, you get 1 over 1/4. And then, 1 over 1/4 is 1.25. And that should be your answer. Okay. So we can tell this is convergence by GST. Okay, that's number 17. Okay, next up, what do you guys want me to do next? Okay, someone in the chat wrote 18. Okay, I'll do 18. So, 18. 18 is sigma infinity n equals 1, okay, n over sine n. No, I'm glad you asked, but no, we don't have to do 38. 38 uses the integral test, which we have yet to learn in class. Okay, so here is which one? This is number 18. Okay, n over sine n. Okay, that may look complicated, and I assure you it is not, but let me just refer to my trusty notes. Alright. So, n over sine n. What do we use? So far, we've mainly been using GST, geometric series test. But we also have other types of tests. And the next type of test that we're going to use is called the nth-term test. So what do we do here? We completely ignore the sigma. And we change this to a limit. Limit as n approaches infinity of n over sine n. I mean, it doesn't get easier than that, right? Well, what do we know about this? We know that sine will just keep on oscillating and will keep on growing bigger. So the limit will not equal 0, right? Yeah, that's what we can assume. That the limit will not equal 0. And that is what we need. Because if the limit is not equal to 0, then we know that by nth term test, this series diverges. Okay, perfect. So that's what we can conclude from this one. And since we know that it diverges, we can also say that there will be no sum. Okay, next. Oops. Okay. Let me pick up the good notes. So we did which one? We did we did 18. What next? What do you guys wanna do? Uh, 13 and 14. Okay, I got you. They kind of look complicated, but I'll help a brother out. Okay, so 13. What do we got? Not integral. This is sigma. Summation, yeah, sigma. Infinity, n equals 1. By the way, sorry guys for the technical difficulties earlier. This is one of my first labs, other than chess labs, but yeah. So, this is a really cool experience. N squared plus 2 over n squared. Okay, okie dokie. This looks really scary. But, don't worry, we know that we know that this is not GST. Why do we know that? Well, we know that simply because we don't have the parenthesis to raise to the nth power. We don't have R, we don't have A, so yeah. We're not dealing with geometric over here. So, since we're not dealing with geometric, what are we dealing with? Well, if it's not geometric series, then it's nth term test. Okay, so we determined that it's not geometric. Now let's commence nth term test. So what does nth term test say? Well, what you do basically is ignore the sigma. Limit as n approaches infinity of n squared plus 2 over n squared. Okay, well, this is pretty easy. N squared, they have the same degree. And what you do, you don't worry about the 2. You get 1. Because this is 1, this is 1, 1 over 1, you get 1. Okay, I guess it cut off. So that was number 13. So what I had done was I found the limit as n approaches infinity of n squared plus 2 over n squared, and then we know that we only care about the highest degree, so we have n squared, and then what we do is basically 1 over 1, which is equal to 1. 1 is not equal to 0. And since 1 is not equal to 0, we know that by the nth term test, proves series diverges. Diverges. Okay. Yeah. So there you go. That's the long and the short of it, of number 13. So, you guys got any other recommendations? Okay. So now, but I saw that someone wanted number 14. So let's do that one. So integral as n equals 2 goes to infinity. Integral. Why am I saying integral? Calculus AB torture. It's not. Alright. So sigma n equals 2 to infinity, and then we're saying number 14. So n squared over natural log of n. Okay, natural log of n. Yeah, whenever you see logs, it's not a happy day. Natural logs and logs, they make things a lot more complicated. But it's not too complicated if you think about it, right? So, what do we see here? Let's use the trusty hand. We see that n squared over natural log of n, this is not geometric, obviously, because we don't have a r to the n or n minus 1. So that. So since we know that this is not geometric, it's the other one. And what's the other one? The nth term test. So nth term test, forget about the summation. So limit as n approaches infinity of n squared over natural log of n. Yep. And then what do you do? Well, this looks really complicated, really fast, but don't worry. Let me look at my notes and I'll be on a jiffy. So, remember a little thing we learned in Calc AB called L'Hopital? Well, that comes back. We have to use it here. Alright. L'Hopital is used, and then so basically this becomes 2n over 1 over n, so it becomes 2n squared, and we know that n goes to infinity, right? Yeah, right. 2n squared is not equal to 0. So there you have it. By the nth term test, series is divergence. By nth term test, series is divergent. Any more? Nobody wrote in the chat yet, but yeah. Okay. I'll do one more. I think I'll call it a day. Since nobody wants any more. So, yeah. You know what? Let's do 20. Let's have some fun. So 20. We have integral to infinity of n equals 0, e to the n over pi n plus 1. Let's check footage really quick. You need 12 again? I'll do this one, then I'll do 12 again. So, integral, I keep calling it integral. That's going to be a pet peeve of mine. Okay, so summation n equals 0 to infinity, e to the n over pi n to the n plus 1. Okay, I hope I wrote that correctly. Yeah, I did. So that's number 20. Yippee. Alright, okay. So we're working on number 20. What do you know? Let me find it. So what do we do? Well, we want to see if this series is geometric or not. So what we would do is we would try testing it out, right? A2 over A1 is the first one, and A3 over A2 is the second one. Okay, So remember, A1 is the first number in the series. Okay, let's go. So A2. So the first is 0. So the second one in the series is 1. Don't be fooled by the 2. So 1. So wherever you see an n, you gotta plug in 1. So that becomes e over pi to the pi squared, right? Over, and then the first one is 0. So e to the 0 is 1. Pi to the 1 is just pi. So, okay, if you can see here, e over pi squared over 1 over pi, you can just do e over pi squared. So pi squared, you cross out the 2, you cross out this pi, and you're left with e over pi. Okay, now let's go to the second one. So I'm trying to do equals, okay. Didn't come out how I liked it, but it's okay. So the third term in this series, 3. No, it's not 3, it's 2. So you plug in e squared over pi to cube over, and now we have over the second term of the series, so we do 1. E over pi squared. Okay, so if you look at this, e squared, e, you cross out the 2 here, you put a 1, you cross out this e, you see pi cubed, you cross out this 3, you put a 1, and you cross out this pi squared completely, and what are you left with? Whenever the dust settles, you're left with e over pi. Alright, e over pi, these both match, they're the same, so check mark, we have geometric series. So, since we have geometric series, A2 over A1 is also the way you find R. So, our R is E over pi. That's amazing. Okay, so we know our R. Now what? Well, since we know geometric, we write R over here. R is E over pi. What's the value of E? Something like 2.7, 2.8, down around there. And then pi is 3.1415 something. So 2 over 3, that is not equal to, why not? We compare that to 1, the absolute value of this R, we compare it to 1. So E over pi is obviously less than 1 since E is less than pi. Pi is bigger. So less than 1, perfect. So since it's less than 1, we know that by GST, series I hope 20 got across, guys. But so what we did was we found it was what was A2 over A1. We found it was A3 over A2. I'm talking about 20. We saw that they matched. Both of them were E over pi, right? So we saw that they were E over pi, and then what happened? So whenever we saw that they were both E over pi, we knew we had found their R. R was E over 5. And then what do? When you get the R put inside absolute value compared to 1, E over pi is less than 1. So we found out that there's convergence by GST, right there. And then the sum, all we did was we used the A1 over 1 minus R, and we found that it was 1 over pi minus. Yeah, sorry, but I'll give the quick version of that, and yeah. So next we were told to do 12 by a viewer. Okay. 12. So what does 12 say? Integral, non-integral, summation, infinity, n equals 0, 5, 3 over 2 n. Then, okay, so off the bat, a r to the n, this is our r. So r is 3 over 2. What do? We compare the absolute value of r to 1. 3 over 2 is obviously bigger than 1. So we know we have divergence by G S T. Okay, next, we're told to find the sum. What do we do with the sum? Sum, we use the formula A1 over 1 minus R. So A1 is what? A1 is 5. Because here, look, it starts at 0 for the first term. So if you plug in 0, we have 1. 1 times 5 is 5. So 5 over 1 minus R is 3 over 2. 1 minus 3 over 2. And then we saw that we got 1 minus 3 over 2. Yeah, we saw that. 5 over 1 minus 3 over 2 is 5 over minus 1 half. Minus 1 half. If you like multiply it, right? It becomes minus 10. Was that right? That was for number 12. Oh no, I committed a mistake too. So why are we finding the sum? That's a mistake. If we have divergence by GST or divergence by any other test, we cannot find the sum. There is no sum. So yeah, that was a good learning moment for you guys and myself. So whenever we have divergence, we do not find the sum. Yeah, that's number 12. Anything else? Let's just check footage. What does the chat say? Alright. I guess I'll do one last one and then we'll end the day on a good note. Alright. So I guess you guys want me to do we don't take the fault. That's fine. It's fine, guys. Alright. Let's do 27. 27 looks fun. Alright. So for 27, we got summation. We got infinity on top. We got n equals 0 on the bottom. Then we got n factorial over e to the n. Alright. This is number 27. So what do you do here, guys? So this is obviously not GSC because if you see factorial, then you can forget about GSC. Alright. So what you do here is you basically what do you do? So we said it's not GSC, right? So forget about GSC. If it's not GSC, go to your next best friend, nth term test. Nth term test, what do? You make this a limit. Summation becomes a limit. Limit as n approaches infinity of n factorial over e to the n. Okay, it becomes a limit. We know that this numerator will grow. It will grow really big. This one, not as fast though. So if this one grows like insanely big, really fast, then obviously we can tell that it will not be 0. Yeah. We know that these two are growers. So limit will obviously not be 0. And by the nth term test, we have just proven, by nth term test, we have proven series to be what? To be divergent. Yeah. By nth-Term test, we have proved the series to be divergent. Can we find the sum? No, because it's divergent. Alright. Y is 13 nth. I used GST and I got a number less than 1. Okay. 13. Well, I mean, if you look at the answer key, sometimes you can use both. You can use NTT and GST in some cases. So it was number 13 the question was on. So 13 is integral n equals 1 n squared plus 2 over n squared. Okay. So I guess it's just what comes to your mind first. For me, NTT comes to mind. Let's look at the good notes. Yeah, NTT comes to mind. Let me show you how. So we got. The thing is, NTT is something that you could do regardless of if it's GST or not. So that's the good thing about NTT. If you can do NTT, that's the easiest thing you can do. You want to go always for the easy things. So limit as n approaches infinity of n squared plus 2 over n squared. We see that n squared and n squared have the same degree. So since they have the same degree, 1 over 1 equals 1. This 1 is not equal to 0. And since it's not equal to 0, by NTT, we have proven series to be divergent. Yeah, since it's not equal to 0, this by NTT we have proven it is divergent. Does that clear things up? Why is 13 NTT? I used GST and I got a number less than 1. Got a number less than 1. Well, let's look at it from your point of view. So n squared plus 2 over n. Okay. So before the video got paused, I was saying that if you do A3 over A2 and A2 over A1, you see that you get 54 over 44 and you get 1/2 as your ratio. And obviously they don't match. And since they don't match, you don't have a geometric series. And since you don't have a geometric series, you can't use GST. But sometimes you can. But not in this scenario, obviously, because it's not a geometric series. So in some cases, you can use GST and NTT. So what next? Any other questions? I think it's getting late, so I'll call it a day. And yeah, I hope you guys had fun with that. I sure did, and I hope you guys learned a lot about series. Thank you, and have a great day. How do we end this thing?